Assalamualaikum warahmatullahi wabarakatuh. Ini kita lanjut ya ke part 2-nya ya. Oke.
And the base, the bottom story, the full structure will be exposed to wind. Let's take a look at another graphic. Okay, see figure 3.1 here. Now this, I'm just pulling some of these figures from our lateral loads manual. Gives a good representation of how loads are distributed to the diaphragm using the extents of diaphragm method. So here we see a building elevation on the left-hand side, exposure width for the second level diaphragm as well as the roof level diaphragm. This is a good representation of our model, which does have a penthouse level. You can see the wind loading at the roof level will be applied using half the height of the roof. And then the wind loading at the second level will be similar, except half the height of the roof as well as the second story will be considered in load application. Okay. We've taken some time to define a wind load pattern. For this rigid diaphragm, why don't we run the analysis and take a look at some output and spend some time on that. Okay, once this is running, you'll notice, as I mentioned before, the load distribution of how the loads are applied to the structure, if you're using a semi-rigid or rigid diaphragm, are different. So we can take a look at how the loads are displayed in both of those scenarios. Okay, the analysis has been run. Now let's take a look at some loads on the structure. To do that, we can click on Display, Load Assignments, Joint Loads. The wind load pattern, which we have defined, load type can be forces, and we'll have the program show the loading values. Let's take a look at this in plan view. So click on plan. Let's start off with the penthouse roof level. And you can see that because I was using a rigid diaphragm, all of the lateral loads are being applied to the center of mass. So if I step down to each one of these floors, this is the wind load that is being calculated and applied to each one of the floors. So let's take a look at a few different ways to take a look at output here in ETABS. We looked at load assignments. Let's take a look at some story response plots. So you'll see here the display colors are blue represents global X, red is global Y. Let's take right now we're looking at maximum story displacement. There are a few different options here. Lateral loads to diaphragms, you can see here we get a graphical representation of the lateral loads which are applied to each one of the floors. And you can define multiple wind load patterns, different story ranges. All of these options are available to the user. Diaphragm drifts, maximum story displacement, as well as story shears. Now all of these graphs can be, of course, viewed on the screen, but they can also be exported and printed in a nice report format as well. And I'll show you that next. Okay, you'll notice on the Model Explorer here on the left-hand side of the screen, there's a Reports tab. So if I right-click on this project report and we click on Modify Report, you can take a look at all the options available in generating a report. It's a very user-friendly report in the sense of the user has complete control as to what they wish to have included in this report. So for the sake of this presentation, we're looking at auto wind loads and auto wind calculations have been included in this report. So if I click Create Report, this just takes a moment to run. Okay, it's just in the bottom left-hand portion of the screen, you can see that it's just finishing the analysis results. And now the report viewer pops up. I'll make this a little bigger, easier for everybody to see. You'll notice the table of contents located on the left-hand side, including all the basic definitions, story data, point coordinates, line connectivity. But what we're interested in here today are the auto wind loads.
Jadi yang dicentang itu nanti ya, yang sebelumnya itu kan checklist ya. Nanti kalau kita mau ambil beberapa ya yang di checklist aja, nanti jadi laporan ya. Kalau tadi kan masih banyak ya yang nggak di checklist.
So if we scroll down to load patterns, it gives you all the information for load pattern definitions, the code you used, the diaphragm locations, as well as the definitions. We'll take a look at auto wind calculation. So this is a very useful tool. I'll make this a little bigger. So it's not such a black box. You can see the exact variables that were used to calculate the wind loads here in ETABS. Exposure from the diaphragms, exposure category used, all the different coefficients, all the different factors, velocity, pressure are calculated. And if we go to the next page, here's that image that we'd shown using the story response plots. Lateral loads to stories, excuse me, have been printed here for each one of the different levels. The lateral load application has been applied to each one of the stories in a graphical format, and also you can see the information here in a tabular format. Now for this specific example, all the loads were applied in the X direction. Okay, let's take a step back here. Everything I've shown you so far is related to a rigid diaphragm. I've created a similar model, except in this model, all of the diaphragms were assigned as semi-rigid. And I wanted to spend some time showing you the differences in load application between the two diaphragms.
Ya, dia mau perbandingin ya. Tadi kan rigid ya, sekarang semi-rigid ya.
Types of diaphragms. So let's quickly run this model here. So after this model runs, we're going to take a look at some auto cladding, apply some cladding to the structure and apply wind pressure coefficients to that. Okay, this model analysis has run. Let's take a look at display, load assigns again, joint, and that same wind load pattern, except this time, remember, a semi-rigid diaphragm has been applied. Again, we'll take a look at this in plan view. So you'll notice a difference here. For the semi-rigid diaphragm, to avoid stress concentration, semi-rigid diaphragm applies loads to 10 different points along the perimeter of the building. So if I step down here, instead of having the point load applied at the center of mass, you'll notice that loads are applied along the perimeter of the structure. And that is the main difference between semi-rigid and rigid diaphragm load application. Okay, and then just lastly, we'll take a look at display story response plots. And we'll make sure we select a wind load case, and we'll also look at the application of loads to the diaphragm, this time semi-rigid. Okay. Let's look at this model in 3D view. I'm going to unlock the model now. Okay, now under the draw menu, let's talk about adding some cladding to the structure and then applying wind pressure coefficients to them. So under the draw auto cladding. Cladding consists of shell objects with a none section property that are added to the outermost perimeter of the structure.
Oke, kita lanjut ke part 3-nya ya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.